Okay, so we're going to try to show that the shape inside is a parallelogram. So that's our shape there. There's two ways we can go about it. The first is to show that the opposite sides are parallel, so the same slope. And then the other part is we show that those opposite sides are congruent. So congruent will be with our distance formula. Slope will obviously be with our slope formula. Before we can do that, we have to determine where these points are. Now they're given as these midpoints, and so we'll use our midpoint formula, which just adds up my x values and my y values and then divides by 2. So you can see I took the x value plus 0 and then the 0 for the y value plus 0 and divided it by 2, and I got E0 for point U. Do the same thing with my other points. So I take for t, I take my x values, which is the 2a and then 0, and then add that with the 2b and 0, and I get AB for point T. And then I'll quickly go through the other ones. I take W, add the x values, add the y values, divide by 2. I get A plus C, and then comma B plus D. And then for V, I add the x values and the y values, divide by 2, and I get C plus E and D. And so now what I want to do is to go through and show that I have the same slope. So if you remember, the slope is going to be the difference in the y's. So this would be a y value, that's a y value over the difference in x, over that, right? Rise over run. So if I do that, I'm going to find that b plus d minus b over a plus c minus a leaves me with d over c. Same thing at the bottom. I get d minus 0. So here's my d. There's my 0 over c plus e minus e. Those are my x values. And I get d over c, which is the same, which means they're going to be parallel. If I do the same process over here, I get for the slope between t and u, right, b minus 0 over a minus e, and then the last one over here, I get b plus d minus d over a plus c minus c plus e, and it's going to work out to be the same slope as we go through this. Alright, so I have that they're parallel, right? What I need to now show is that they're congruent. And so to show that they're congruent, I'm going to use the distance formula. So here's my distance formula. If I look from t to w, right? So from t to w, that's going to give me my point, the distance over here from t to w. And I just use my coordinates, the difference in x values squared plus the difference in y values squared. I simplify it and get c squared plus d squared all the square root. That is not equal to c plus d, so we're going to leave it like that. And then for uv, alright, uv is over here. I'm going to take the difference in my x values, so c plus e minus e squared, d minus 0 squared is the square root of c squared plus d squared, which is the same as we had over here, which means the distance is the same. And we do the same process for the other sides, and we can show that all the sides are congruent. So if all the sides are congruent, it's going to be a parallelogram. It's going to be a rhombus. The first part showed that it was a parallelogram.